Welcome to the Coulomb's law exploration. In this exploration, we will apply Coulomb's law and Newton's laws in two dimensions to determine the net charge on an object. In particular, we will be trying to count actually the tiny little electrons that are either missing from the balloons or in excess on the balloons. We do know both balloons have the same charge, but we're not sure yet whether they're positively charged, which would be a deficit of electrons, or negatively charged, which would be an excess of electrons, but they are repelling each other, so they are like charged. And again, by the end of this exploration, we should be able to actually count the number of electrons either missing or in excess. In doing this, we will be revisiting old ideas, so we may apply them to a new situation. In particular, we want to develop an expression for determining the horizontal force acting on the pendulum bob needed to displace the pendulum bob an angle phi, equivalent to a displacement delta x. Our task for this part of the exploration is to determine the algebraic relationship between the horizontal force, F, shown here, and the parameters mass of the pendulum bob, the length of the pendulum, the displacement in the x direction, and the vertical rise, the displacement in the y direction. So we want to develop that expression. In doing that, we will draw on old strategies that we learned in past units. We will draw a force diagram showing all the forces acting on the pendulum bob. The force of gravity acting straight down, the tension in the string acting along the cord here, and of course the horizontal force pushing the pendulum bob to the right. The next step would be to break the tension force running along this cord into its x component and its y component. And then we will apply Newton's second law separately in the x direction and in the y direction. We'll get two separate equations from those two applications of Newton's second law, and we'll combine them and solve these equations simultaneously to get one relationship that will give us an expression for computing the force as a function of the mass, the length of the pendulum, the horizontal displacement, and the vertical rise. All right, we just moved the diagram off to the left, so we have a work area to talk about the strategies that we just presented in the last presentation. The first part of the strategy would be to draw the force diagram. So we've shown this first force. This is the actual force pushing the pendulum bob to the right. We then would add the gravitational force acting vertically downward and the tension force acting along the cord of the pendulum. The next step would be to break any forces that are not in the x and y direction, the only one being the tension force in this case, into its x component in this direction and its y component in this direction. Once we have the force diagram and we've broken the forces into the components, we would write Newton's second law both the x direction and the y direction. So we'd write the sum of the forces in the x direction equal generally max, but in this case, since it's in equilibrium, the acceleration in the x direction is 0. It is not accelerating in either the x or y direction. So the sum of the forces in the x direction equals 0, and the sum of the forces in the y direction also equals 0. What we then proceed to do is to actually add up all those forces in the x direction and get a expression that relates some of our variables. And we would then next add up all the forces in the y direction, get another expression that have some of the same variables and some other variables in it. We would then look to combine these two equations to eliminate the variables that we would like to remove and eventually end up with a single expression with the force as a function of the mass of the pendulum bob, the length of the pendulum, the displacement in the horizontal direction of the bob, and the vertical rise of the bob. Well, we'll leave it now for you to do this. So I'm going to pause the, you may want to pause the movie to copy down this picture to make a sketch of this procedure. And your goal as we leave you before we do the next video is for you actually to come up with this relationship. So follow the steps, draw the force diagram, break the tension into the X and Y direction, add up all the forces in the X direction, get an expression, add up all the forces in the Y direction, get another expression, combine them, and come back in about 15 minutes with your expression. We look forward to seeing you then. Good luck.